All right, and
Okay.
Bogdan, please, the floor is
Yeah.
yours.
Yeah, thanks. So, hi everyone. I'm really glad to see everybody here. So, let's start. We will talk today a little bit about me. I'm a DevOps engineer. I like to automate a lot of things, like to use different tools, Jenkins, GitLab Actions, and so on, so on. I like to secure everything. I don't recommend to store any credentials or something like that in the Git repository or on the some paper notes. It's not good, and I'm not so good in PowerPoint and presentation. So let's continue. Today we're going to talk about cloud native solution. What is it, and what we're going to use for it. We will talk about scaling with Kubernetes services. Uh, Take a word about serverless technologies. What is it, and what is better to use? How to build resilient environments, and a little bit about security. So after that, after presentation, you can ask any question. So let's start. Cloud native solution. What is it? Basically, this is the tools. This is things when you put everything what you have in the cloud providers. For now, we have like a lot of the biggest providers. It's AWS, Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Basically, they are similar to each other, and you can use a lot of different tools inside. But the main problem that they not compatibility between. So we will talk about it a little bit later when we go to the serverless. Both of this platform provides you fully covered cloud native solution. Doesn't matter, is it Kubernetes or just servers or some Lambda function, Cognito user pools, doesn't matter. So let's go next and let's talk about Kubernetes a little bit. So first of all, let's discuss the benefits and disadvantages. Uh, Benefits, its scalability, high availability, load balance, efficiency, ecosystem integration, and a lot of other things. But on the other hand, we have complexity, uh, vendor locked in. It depends about vendor lock-in because mostly all of the tools that you're going to use on cloud native technologies are vendor lock because on AWS, for example, Kubernetes called AKS, EKS, Elastic Kubernetes Service. On Microsoft Azure, it calls AKS. On Google Cloud, it calls Google Kubernetes Engine. So basically, all these things are vendor locked. And it's the most biggest problem. It's overkill for small application. For example, if you want to run something like a WordPress website with basic database, MySQL, and so on, you don't need to have Kubernetes for it because it's really a big platform. So the main tool, why people love to use Kubernetes, because it have a lot of benefits, as I told before. Let's talk a little bit about them. So internal CI/CD processes in the Kubernetes, they can recreate your application, for example, if it failed by some reason or has some problem inside, then it will recreate or make a rollback process for it. Automatic scaling, the most interesting things because you can scale it horizontal, like you have one container and you have a big load for it, and you start scaling it from 1 to 10, 20, 40, 100,000, and so on. And this mechanism works basically with your load. You can configure it for CPU usage, memory usage, or even for requests. For example, let's take a look. If we want to use some queue messages and some queue for our service, we can scale our application on Kubernetes based on these small things like with the queue number of people. The next good things is load balancing. So doesn't matter you have thousands of applications, they are scaled every time you have first endpoint that called service, and you can use it to provide access for all of your application that should be scaled. And service discovery tools, all your application are accessed inside of the network from the different places, but inside of the network, you can every time access by the name of the container or host name or service, doesn't matter. So basically, to make your application, you need to have some small solution. First of all, you need to design a really good design for your application, because if you will have something like you will not know about what you want to have. The application will be failed from time to time because you don't know the process, how to make it. Okay, now let's talk a little bit about serverless technologies. Basically, what is it? It's the same cloud native solution, but you don't need to use any of the resources like Kubernetes or EC2 instances and so on and so on. You can use, for example, let's imagine that we have some small application that want to get image. When the user login to the website, you need to send image and make some call, I don't know, make some other API call. So we can use like basic things, Cognito for user management, AWS Lambda to make this response with the image, and as Amazon S3 bucket. All these things, it's serverless technologies. The same tools you have also on Microsoft Azure, on the Google Cloud, and on other different cloud platform, but basically it's everything the same. So the benefits and disadvantage. First of all, it's cost efficiency. It's a benefit because you can fastly make a small application to use small services with the small resources, and it will cost not a lot, and you can run application fastly. The next benefit is faster time to market. So this is also a lot of startups like to use this benefit, because you don't need to have the team that will control your servers, clusters, and so on, so on. You can, by clicking of the mouse, just create a small application, and it's not overheaded. Also, the disadvantages: it's limited control. The call start as usual vendor lock-in, because each of this you can build the system split it between different clouds, but it required some outbound calls. So for example, if you send a request from the Amazon to Google Cloud, you need to go through the internet. You cannot connect them between fastly. Also, this problem, it's a resource limitation. For example, for some of the services, you have some limits to use memory, CPU usage, especially for Lambda, because it's required some things, number of calls, throughput, and so on. And from my side, the biggest problem is debugging complexity. You do not have any logs. If you not configured it, you don't know where it failed, because, for example, if your user go to the login via Cognito user pool and image not returned, you need to go and find out, is it image not on does it image not on Amazon S3 buckets, or Lambda doesn't provide it, or some gateway networks, and so on, so on. You will just jump from service to service. So basically, what is it? Serverless technology. You have web app. Your web application, doesn't matter, it's Android or UI browser. You would go to API gateway, and this API gateway send the traffic between different things. As I said, you can as user service, we can use Cognito user pool. As external database, we can use something like Aurora DB, MongoDB. It doesn't matter where you are going to store it. Depends on the cloud provider. You have different type of database, and what is interesting, each provider has own database, like that they create for some usage that they think that it's good. Content services, as I said before, you can put some images on S3 buckets for some, I don't know, put some part of the code or functions on Lambda functions, doesn't matter. External API and authorization. So from the AWS perspective, user services and authorizer, you can use the same Cognito user pool. It's a really big and beautiful tool for it to just make authorization based on the two-factor authentication, or even GitLab, GitHub, Google, Facebook accounts, and so on, and you can have the control of the users there. So what I want to tell more, you can decide what the tool, what you prefer to use, how you're going to use it, but the main idea is to build resilient environments for it, because everyone wants that his application, product, doesn't matter, will not fail at all. But even big cloud providers do not provide you with the 100% of the that you will not be failed, because we have something like disasters and so on, and they also have a data centers. So basically, if we are talking about Kubernetes solutions or serverless solution, under the hood, you have the same servers, but these servers located in different regions, they connected with the power cables, with the high network speed, like gigabytes of connection speed, and so on. So now let's talk a little bit about resilient environments. So the main key point from my side that I want to mention, it's redundancy. First of all, when you build your environment, doesn't matter, is it serverless or you build it on cloud, on Kubernetes, or even on premise. If you can split everything that you can between different location or servers or regions, just do it. Believe me, if you will have some interruption in one region or server, and all your application will be hosted there, you will be in trouble. After scaling, this is the right design of the system that you should scale your application servers. As usual, doesn't matter, is it Kubernetes or serverless technologies or even on-premise service or bare metal. You need to design mechanism how you're going to scale your application. Okay, it's easy to scale front-end side. Yes, it's just a website page that can be scaling up and scaling down. But with the another side, we have backend side. For example, we have some payment methods, right? We make a technology stack for education and have some payment method. And in this case, we just launch our platform and people start register, get some courses, doesn't matter what, and your application starts scaling. In the end, when number of requests, CPU will go down because users go to check something else, your application will be scaling down. And in this case, you could face the biggest problem. You don't have cold shutdown. When the application you should have cold shutdown. When the application stop getting any connection to the backend side, and after the latest connection, it will be stopped without any impact for transaction or something like that. The next case from my side, it's health checks and monitors. You should monitor as more as you can. Even it will be small PIDs processes inside of the container. It will be a number of people in queue when they try to log into your platform, or I don't know, number of the requests to your platform. You should see everything, because most of the problems in the high-level traffics. And I want to tell one small thing. Some time ago, we were designing the system that based on SLA. So basically, we start getting alert only if the latency or response from the websites, from the portal, take more than half a second. And it's also good, but in this case, we also monitor the CPU usage, RAM, and so on and so on. Besides, all this monitoring system in serverless help you to decrease the costs, because if you will see that your some functions, doesn't matter what, it's Python, Node.js, .NET Core, .NET, some functions on some script take a lot of resources, and you can find out it by the monitor of the resource usage or cost planning. And one of the important thing, but no one talk about it, and no one know, no one design it from the beginning. It's a disaster recovery planning. What is it? Just imagine that you build your system in some of cloud providers. Doesn't matter. Let's take Alibaba Cloud, for example. And something happened, and they fully destroyed. Like they don't have data center in some of the region. What the problem you will face? You face the problem that your application is down. Your customers cannot access it. You lose your money, you lose your customers, they can go to another company, and so on, so on. And in this case, you need to plan disaster recovery. The biggest problem why people do not like to plan it, because less time to restore of the system take more money, because you need to involve a lot of people for this process. For example, we have two developers, we have some DevOps engineers, network engineers, marketing, and so on, so on. And when you build this system, you need to involve the resources, you need to plan it, you need to have the right processes. For example, to store your code in different repositories, have a backups of the database. Doesn't matter if the database will be locally on the cloud, or it will be on the server, or serverless database. You need to make a backup, and you should have access from them, and you should backup it to the different places. And backup of this database, if a big database, it's the size. For example, it's 100 gigabytes. It also costs. So this is the biggest problem. People don't want to build disaster recovery because it's cost money, a lot of money. But from my side, it's the first recommendation. Before you start, just plan the disaster recovery. How fast you want to restore your system from scratch without losing minimal data. Okay, let's go next. Let's jump a little bit to security part, because doesn't matter we use serverless technology, Kubernetes, even on-premise servers, or even, I don't know, maybe someone will run some platform on the laptops. You should know about the security, because let's take a little bit in another way. Maybe someone here from you heard about the Have I Been Found website. You can type your password there, and it says how many times this password was leaked from different system. Just imagine that some tools like one password, keep pass, and so on has leaks of the system with the password, a lot of password because they are stored in the cloud. So basically, a lot of passwords can be splitted by different people and it could be used. And that's why you need to think about the security. You need to secure your infrastructure to close totally as more as you can. So for example, if it's under Kubernetes solution, you need to close the networking. Your networking should be in the private network, not in the public. So to your network should be accessed only via load balancers or some gateways or VPN tunnels, doesn't matter, but it should be secured. Data security. Everybody knows that a lot of people like to store some environment variables in different places, like in the Bitbucket, for example. You have some keys in the Bitbucket that uh, not a keys. You have credentials to access to your database, and it's stored in the code, not encrypted way. Now, if person gets inside of your system, they will get these credentials, and you probably lose your data. This is how it works. Application security, as I was telling before, if you use your serverless technology for it, you should have like two-factor authentication with the Cognito or login with other services and so on, so on. I can tell a really interesting story. I was watching some of the videos about cybersecurity, and one person said that, okay, someone came to me and said, I want to hack my X login and password. Yes, they provide the money and so on, so on. And in some period of time, he said, okay, let's do it. And provide in the 15 minutes login and password to some of the Instagram, I don't know, Facebook, doesn't matter, some of its page. And this person said, oh, great, try to log in and can't because he faced two-factor authentication. So what is security? Even if your password could be leaked, doesn't matter, database or something like that, you should have some other preventive method to prevent any accesses. Rotate your keys, change your password, and so on, so on. Another two, last but not least things, it's events login. This is the really beautiful things like on the cloud native solutions. You have you can write anything that you want, starting from the login to the system and from the changing some letter in the code by login, and you can see all the changes on there by for example, if you build serverless technologies, you have some Lambda functions that's not uploaded by CI/CD tools because we are startup. We don't want to spend a lot of time to our application. We just put it like a copy paste it to the Lambda functions. And you can see if someone go and change something there in this small function, small part of the code. And yeah, it's great because it could broke your system. It could broke the portal at all and so on. And the last thing that I want to tell about it's testing, vulnerability testing. Different people call it in different way, but you need to know how to test your system for some injections. We know, everybody knows about OWASP top 10. Yes, it's like a top 10 basic things that you should do for your website or application or portal or, I don't know, some payment things that will provide you like 10 steps to secure it. Basically, it's not only 10, but it's the basic things like logins, security, network security, and so on, so on. But in the end, you want to test it somehow. You can have some corporation or another third-party services or tools that will test your system, but you can build yourself your self-hosted system that will not cost a lot of money, but it will provide you like a basic security analysis. They will say, this system tell to you small things that you have some vulnerabilities, you have some XXS cross-site scripting, the injections or data injections or so on, so on. So basically, from my side, I'm done. Do you have any questions?